In this video we're going to talk about the Lesson 12.3 worksheet, Law of Sines, and do some selected problems. So let's look at number 2. He wants to find the area of this triangle. Now, to use our area formula, remember we have a couple of formulas for area. We have a side formula for area. Let me bring these up here and review these real quick. Our side area formula is Heron's formula, or Hero's formula, which is a semi-perimeter times the difference of the semi-perimeter on each one of the sides, and you take the square root of that. Also, we have an SAS pattern formula where we do 1/2 the two sides that they give us times the sign of the included side. So we've got two different formulas that we can use depending on what we're given on these. And also we have a traditional areas 1/2 base times height formula. So let's see what we need to do. Let's look at number 2 then. So they're telling us that this is an isosceles triangle. So that means that this is an 8.7. And if this is triangles isosceles, angles opposite congruent sides are congruent. So that lets me jump that 70-degree angle over to the other side. Triangle sums lets me find this angle that is the included angle between these two equal sides here, and these two congruent sides. 70 and 70 is 140. 140 from 180 gives me 40 degrees for that angle. So I could use the k equals 1/2 AB sine theta formula, because 40 is the included angle between the two sides. It's the hinge, and the two sides are 8.7, and the other one's 8.7. So I have 1/2 times 8.7 times 8.7 times sine of 40 to calculate the area for number 2. So 0.5 times 8.7 times 8.7 times sine of 40 comes out to be 24.32. They want us to round to the nearest square unit, so 24.3 rounds to 24. Or we could write 24.0 to show that it was rounded off. Let's look at number 3. Now for number 3, they're telling us that we have a trapezoid. We've got the two parallel sides. They're not saying that it's an isosceles trapezoid. And they're telling us that this one side length here is a 5, and this angle is a 55. So with alternate and with supplementary same side interior angles, we could figure out what that angle there is. We can't really do anything with diagonals and triangles because we're not going to have congruent triangles or anything. So what I see going on with this one is we're going to have to use the area of a trapezoid formula, which is 1/2 the sum of the bases times the height, or the average of the bases times the height. So we have area is base 1 plus base 2 over 2 times the height. Now to figure out what the height is, we can look at that triangle on the left. We have a 55-degree angle. The height that we need to find is opposite the 55, and we have a hypotenuse. That lets us use a sine ratio to find out what the height is. So sine 55 is equal to h over 5, or 5 sine 55 is equal to h. So let's see, 5 times sine of 55 comes out to be 4.09. So we'll call this 4.1 for right now. So now we can go to the area formula. For the trapezoid, we have base 1 plus base 2, which is 8 plus 14, which is 22. 22 divided by 2 is 11. And 11 times the height, which is 4.1, gives us 45.05. Gives us 45. So this one's a little bit different. I just couldn't right off the bat see a law of sines way of doing that. So, you know, we can use the formula for the area of a trapezoid on that one. Let's look at one of these in the middle. Let's look at, say, number 6 and see what we have to do for number 6. They want us to find n. So this is a more straightforward problem. They're giving us an angle on its opposite side, and they're giving us an angle, and we need to find the opposite sides. That's like a straight out law of sines problem. Sine 50 over n, no, sine 50 over 29 is equal to sine 78 over n. When we cross multiply and simplify, n is going to be 29 sine 78 divided by sine 50. So 29 times the sine of 78 divided by sine of 50 comes out to be 37.02. This needs to be rounded to the nearest centimeter, so 37 is the answer that they're looking for, and the answer is in centimeters for that one. Let's look at number 8. They want us to find Q. They're giving us a 67 and a 37, so they're not giving us enough to actually set a ratio up with the correct numbers that we need, but we could figure out what this angle here is by using triangle sums. And 67 and 37 add up to be 104. And 104 subtracted from 180 comes out to be 66. So this is a 66-degree angle here. Now we have an angle and its opposite side, so we can use the law of sines with that. Let me move this over. So sine 66 over 21 is equal to sine 37 over Q. Cross multiply and solve for Q. Q is going to be equal to 21 sine 37 divided by sine 66. And again, this needs to be rounded to the nearest centimeter. So 21 times the sine of 37 equals, divided by sine of 66, equals 26.69. So to the nearest centimeter, that's going to round up to 27. 26.7 rounds up to 27. And it's in centimeters. So that was pretty straightforward. Let's look at, say, number 10. And see what's going on with number 10 here. Bring this up. So we've got to find those two angle measures. Let's see, they're giving us a sine ratio that we can use with the 48 and the 32. They're giving us an opposite side here. So the plan on this one is to use law of sines, figure out what angle P is, and then these two subtracted from 180 is going to give me angle Q. So law of sines, sine 48. And notice again, there's probably not enough room on one of these pages to do all the work that you need to show for these problems. So just having the answers isn't going to be good enough. You need to show that you set the problem up the correct way. So we got sine 48 over 32 is equal to sine of p over 26. Okay, multiply by 26. 26 sine 48 divided by 32 is going to be the sine of p. So let's see what we get out of that. 26 times sine of 48 divided by 32 comes out to 0.6038. And we want to see what angle goes with that ratio, so we have to do inverse sine of that, and we get 37.14, and this needs to be rounded to the nearest degree, so 37. So I'm going to write down 37.1, but 37 is the angle that they're looking for the measure of P. Now we can find Q. If this is a 37, we have a 37 and a 48, that comes out to be 85. 85 subtracted from 180 gives us 95. So angle Q is 95. Okay, let's do one of these problems from the bottom. Let's see. Let's look at number 15. It says two angles of a triangle have 24 and 69. The longest side is 14.7. So when it says longest side, to be able to know where that longest side is, I have to really kind of think about what the other angle is. If I do 24 and 69, I get 93. Subtract that from 180. Let's mess that up. Okay, so let's do that over again. So 24 and 69 comes out to be 93. I want to subtract that from 180 by adding the opposite, and I get 87. So the other angle is 87. So now, using triangle inequalities, the longest side of a triangle is going to be opposite the largest angle, so we're going to need that. So now I want to sketch the triangle. It says that one angle is 24. Again, it doesn't have to be to scale, but I need to make sure I have the correct numbers in the right place. So if I let 87 be up there, that's the largest angle. The largest side is going to be 14.7. It's got to be opposite the largest angle. Now if they said smallest side, I'd have to put the smallest side opposite the smallest angle. And they want me to find the other two side lengths, so I'll call one of them x and call one of them y. So now this is just a straight out law of sines problem. Sine of 87 over 14.7 is equal to sine of 69 over x. And that's also equal to the sine of 24 over y. So you got two separate ratios to solve. Solve this one, figure out what x is, solve the two outside ones, and you can figure out what y is. So I'll leave that for you guys to finish up. So those are selected problems from the 12.3 Law of Sines sheet.